G'day fellow YouTubers. Today's video is about making a lithium battery out of various different size milliamp cells that you may have, whether they be 18650s, LiFePO4, prismatic cells, or pouch cells as well. So this came out of an Invicta lithium battery here. If you haven't seen my last video, please go back and watch that, and that'll explain why I'm doing this today. So I've gone and fully charged these and then discharged the battery, and I have written on here what milliamps they tested at. So I suggest writing them on the cell and make it a lot easier when it comes down to making the pack itself. So this one's 23,738 milliamps. The rest, so they range from just about 22 amps, just about 22 amps to about 24.5 amps. These cells did. So I'm going to put these numbers into a website that I've got, and I'll put the link in the description, and it'll tell me which cells to put in which pack to make the best possible amp hour out of this battery. So let's get started. So to test my cells, I've been using the SkyRC E680 multi-chemistry charger and discharger. So this does all your types of lithium as well as nickel metal and nickel cadmium, etc. There's a good little unit. So you go through here, you got LiLo battery, LiFePO, all different lithiums, nickel metal, nickel cadmium, a whole bunch of different batteries it'll do. Battery meter, you can do your battery resistance, etc. So for me, we are doing a LiFePO battery, so you'll go like that. I'm charging mine, so you've got charge, fast charge, storage, and discharge. So we're going to put mine on a standard charge, so you would then go start. I'm keeping mine at the 8 amps, because as these cells will handle it. So depending on the cells, if you've got 18650s and whatnot, I suggest you drop that down, which you can do, 7.9, 7.8, all the way down to 0.1 amps. So I'm keeping mine on the 8. We are going that, then we are on the 1S, so it's just the one battery, but you can change it, of course, if you have a 2S pack, 3S, 4S, 5S, 6 is the maximum that you can do. They do normally come with a balance lead that goes in here for if you are doing a multi-pack. I'm not, so I'm just doing the one. So we're going to go with that. We're going to go start. We're all settings where we need to go. You'll only need to do this once if you're doing the same batteries over and over. So you just hold down the start button. It'll check the battery, connection break. So that's just a normal thing. So what will happen is that tells you that the battery is not connected. So we'll hook my battery up with the negative. Yes, I've made a bit of a dodgy lead here with the red, but that's your negative there with the black, of course, and then your positive will hook up as well. So there we are. So we'll stop that, we'll start again. Of course, it realizes there's a battery there, so you just press start, and that'll now go through this charge cycle, and once it's finished, it will give another beep as well once it's done, and give you the how many amps, or milliamps it went into. Right, so we're going to stop that now. And now I'm going to show you how to do it for discharging. So again, we'll go discharge here. I didn't use this particular one. I will show you which one I used down the track with when I discharged the full battery that's complete. So discharge, 2 amp max on a discharge. So this is why I didn't use this one, as it is quite slow. 3.3, you would again do the same thing. Hold the start button down, battery check, confirm. And now it will start to discharge and then give you a reading as well of what was in the battery, which I then have written down here on each individual cell. So this is a 24235. It's best to do that if you can, write on each individual battery, so that way you know what's what. And now we'll get to how to make the pack. Okay, so this is the Repacker website. I'll put a link in the description for you all. So basically you want to go down here to Repacker on the side here, just click on that. So here you want to add in all your cell results from your testing. So just want to separate them all with a comma, not a space, just a comma in between each one. And then you want to add them all in and go add cells. So we're going to have, in my particular instance on my battery, we're going to have 4 cells in series to make the 12.8 nominal voltage. There'll be 5 in parallel, so we'll go 5, and the nominal voltage for the prismatic cell is 3.2 volts. So we'll go generate packs down here. we'll make it into a compact design so we can all read it on the one screen. Okay, so it's going to tell me I'm going to have a nominal voltage there of 12.8 volts with an amp hours of about 119 amps. So that's not too bad for the 125 this battery originally was. Watt hours is 1525. So it'll basically say your first pack of 5 batteries. These are the cell numbers down the bottom here that you want. They don't have to be in order, so you don't have to go 24369 and 24333. You can go 24369 then 23630. As long as they're all in the same pack, that's fine. I got a deviation here of 644 milliamps. 218 on the second pack, 784 on the third pack, and 741 on the next pack. So they're the 4 packs I've got. The lowest obviously being the one up here, so it'll be 11914. That's the lowest pack, so therefore that'll be the amp hours that the battery will be at. Alright, now it's on to packing the cells into the box, and we'll do that now. Okay, so now that the cells have been rearranged according to what I put into the website, it's time to start building this bad boy again. So it's just a matter of popping them into the battery. Alright, so now that they're all in, it's time to get the plastic cover on. This is probably the most time consuming part of it all, apart from obviously the nuts and bolts, but getting this to sit in is the fun bit. Okay, now it's time to screw it down into the 4 corners. Okay, so now that that's done, it's time to stick on the bars and get them where they need to go to help join all the cells together to make it 12 volts. So there's your main positive and your main negative rail here. And then these will join the positives and the negatives together of each pack. So to make them in series, 2 and 3. Now it's time to get all the nuts and bolts on. Okay, so you may have noticed I've left a few bolts off here. So these will be for the balance leads to the BMS. These back ones here will be for the active balancer, and these are your main positive and your main negatives to the BMS, and that one will be to the battery cover. So now that that's done, let's get the rest of it started. So here's the balance leads for the BMS. I've copied them from where they were originally, so they're just labelled on them 1, 2, 3, 4, 5. So they'll be in order. So this one here, being the longer wire, is your main negative, and the short wire here, the blue one, is your main positive. So they'll just go in order. So the main negative, then the first positive rail, second positive rail, third positive, and then the main positive at the end there. Alright, so now it's on to the active balancer wires. Same deal. The black one here being your main negative, and then your main positive, and then of course all the positive ones in between. So I got this BMS active balancer here from eBay. I'll pop a link in the description. The wires come a lot longer than that. I've just cut them down to suit. Okay, so now that all the balance leads are on and in position, it's time to get the BMS sorted out. So this is just a bit of Kmart chopping board that I got, so that'll go on top. Cover these up and the active balancer will sit about there. So it's a matter of sticking that on there like so. That's perfect. Then goes on the clear sheet like so. Now the BMS, so it will go on. I will need to quickly pop on the temperature sensor wire, which will then stick down in here. Just stick it down on one of those there, that'll sense the temperature of the cells. They get too hot or cold. Rightio. Now we put the BMS into place. Okay, so the BMS is in place. Unfortunately, I still couldn't find too much about this BMS to try and get hold of a Bluetooth model. I might try and see if I can get in touch with Invicta. Maybe try and get a hold of a couple of Bluetooth BMSs to stick in these batteries, because I'd prefer that, so I can keep an eye on the cell balancing, etc. Alright, so now it's time to get the negative rail put on, the positive, and then this is the negative to the battery cover here. Okay, so let's put the active balancer in first. So that's it here. I've just stuck some double-sided tape on the edges there, so hopefully that's enough to stick it to that. If it doesn't, I'll work something else out down the track as well. but the plan is to stick it pretty much there. It's out of the way, and then the leads here will come down and plug into it. So let's get started on that. Okay, so now that's in and on, we'll plug the BMS in as well. Okay. Okay, so now it's time to get the main positive and negative on, attach to the box, pop the lid on. Okay. Alright, now it's time to get the lid on. So I was going to seal this up here, but I won't at the moment in case I can get a hold of another BMS and then I can seal it later. I've got some special seal glue that I use on mobile phones. I don't know where it is at the moment anyway. It's got a needle on it. I'll just find down in there to seal it all up. But like I said, at the moment I'll skip that until I can see if I can get hold of a different BMS. Alright, so I've got these guys here. They're no longer sticky like they were, but they'll go down onto that. So I've got a bit of glue that'll do the job. Super glue, just enough to keep them on, to protect them from hitting anywhere on the battery that shouldn't. So we'll just let them dry for a minute and continue on from there. Okay, so with them now dry, it's time to put the lid back on. So, remembering we've got 8 screws here, we'll do the 2 corners up here first, like so. There we have it. Now we'll test for voltage, make sure all is sweet, which it should be. And then it's time to pop it onto a charger, and then we can test it and see what we pull out of this. So, as the computer says, it should be about 119 amps. We'll see how we go. Okay, so here we have it on the Victron Blue Smart Charger, 15 amp. This model is a Bluetooth model, so you can actually keep an eye on it on your phone via an app. Change through the settings, have a play around with it all via the app on the phone. It's a great nifty little device to have. So look, I'm going to let this charge, and I'll go through the app and I'll see how much got put into the battery. So you'll actually be able to see that in the app as well. And then we'll discharge it as well and see how close we got to what the charger put in as well. So just make sure, 8 volts. So So we're currently charging, sitting at 12.05 volts at the moment. So I'm going to let this do this thing for a few hours, and then I'll come back to it and we'll discharge it and see how we go. Okay, so she is fully charged. So we're going to do a discharge test. Today I'm using the Sky RC BD250. There's a software program you can get on Windows that I'm using to use all these. You can use these dials here. So this is in the flashing mode here, so you got your up and down, so you can change how many amps are coming out of the battery. 15, you can go right on up. I think 35 might be the maximum. I'll have a look at the computer. Then you would tap that in. It's done because there's nothing hooked up. So, and then you've got the voltage of the battery as well, but it's reading what the voltage of that one is, so that's why it's at 14. This is your down to your discharge of 10 volts. So you go all the way down. But again, I'm going to use the program on the computer, and I'll show you how to do that now. Okay, so here's the discharger here. So I've got mine offset to custom, and then we'll drop the voltage here down to 10 there, and then I'm going to put the discharge current at 20 amps for this particular battery, or close to. There we go, so we'll do 20.05 amps. So then it's just a matter of going start. And then you've got your chart down here, so we'll go start. So this is now starting the discharge test. That's the current going up. So it's sitting at about 17.8 amps at the moment. You've got your voltage chart as well. It'll slowly start to go down, and then you can get your capacity that goes up as well. So we'll have this discharge. This should take, about 6 hours, give or take. So we'll come back after that and we'll see what we finally get out of this Invicta battery. Cheers. This is just a quick video of showing the discharger working. As you can see, it's 18.87 amps coming out of the battery. I've only just started it, so we're at 13.2 volts and 476 milliamps so far it's taken out. It's got a neat little fan on top as well. It keeps it cool, because all they basically are is they just heat up to create the power, and then the fan will keep it cooled down. So that's how the dischargers usually work. So we'll come back to that in about 6 hours and see how we go. So there you have it. We've tested at 122 amp hours. So with this particular tester, for some reason, they get to 66 amp and then drop and then start again and keep going. So you would add your whatever your end result is, which is 56,925 to the 66 amps that it tested at. So I'm sitting at just under 123 amp hour. So all in all, that's a very good result considering these were water damaged. The second battery tested at about 125 amp. So they're pretty close to each other. I'm going to put these in parallel and set them up, and I'll go into my camper and they'll run an inverter and whatnot for camping. Alright guys, I hope you enjoyed the video. Anything I've mentioned here with the products I've used, I'll pop in a link in case you're interested in them. And I'll see you in the next one. Cheers.